Okay, 2.6 is solving absolute value inequalities. Okay, so this is an equation here. I've got an absolute value equation. The absolute value of x equals 3 means that the distance from x to 0 on the number line is going to be 3 units. Okay, so here's 0. And if we think about the two numbers that are 3 units away from 0, well, you could go 3 units to the right, right? So 3 is 3 units away from 0, but you could also go 3 units to the left on the number line, and then negative 3 is 3 units away. So x could equal 3 or negative 3, and it would work out, right? Absolute value of 3 is 3, and the absolute value of negative 3 is 3. Okay. All right. So with that in mind, let's look at an inequality that involves absolute value like this. So the inequality, the absolute value of x is greater than 3, means that the distance from x to 0 on the number line is greater than 3 or more than 3. Okay, so let's think about that. We've got these 2 points that are 3 units away from 0. So if I want, here's 0, right? And then if I'm going 3 units away, so that puts me there and over here. But if I want to be more than 3 units away from 0, you'd have to be out in this region, okay? So these numbers are not going to be included because this inequality is not, inequality symbol is not underlined. So I'm going to have open dots at negative 3 and positive 3. And I want all the numbers that are more than 3 units away from 0. So I could say x is going to be less than negative 3 or x is more than positive 3. Okay? All right, let's take a look at another one here. So now we've got the absolute value of x is less than 3. Well, that means the distance from x to 0 on the number line is less than 3 units. Okay, so I'm again going to have my dividing points at 3 and negative 3, and they're going to be open dots because those points aren't included, okay? But I need numbers less than 3 units away from 0, and those would all be in this region, right? All of those numbers, 1, 2, or any of those decimals or fractions that are in there are going to be less than 3 units away from 0. So I could say x is greater than negative 3. This should really say and. I'll switch that on the note-taking guide. And x is less than positive 3. Okay? So it's in this region. Okay? All right. So let's look at this next one. It's interesting. So if we have the absolute value of x is less than negative 3, that means that the distance from from x to 0 on the number line is less than negative 3 units. Okay? But you can't be less than negative 3 units away from 0 on the number line. Okay, so if you think about that, you know, if you're at 0 here, you could go 3 units to the right and be at 3. Or you could go 3 units to the left and be at negative 3. But those distances, I went 3 units this way or 3 units that way. So a distance is always positive. If you think about, maybe you live 3 miles away from your school, well, it doesn't matter if you go east to get home from school or you go west. It's still going to be 3 miles no matter what the direction is. So these distances are always positive. Okay? So this is impossible because this would have to be a negative distance. So therefore, this inequality has no solution. Okay, and anytime an absolute value with a variable inside like this is, I worded this wrong. Anytime an absolute value with a variable in it is negative, it's just weird wording. Okay, there is no solution. Okay, so anytime I've got something like this, and it says it's less than 0 or less than a negative number, that means it would be negative, and that means you have no solution. Okay. Okay, next page, let's solve some inequalities then that are a little bit more complicated. So we're going to solve this absolute value inequality and also graph it on the number line if possible. If there's no solution, I'll just say no solution. Okay, so looking at this, I can see this absolute value is going to be greater or equal to 2. So this is going to have a solution. There are definitely places on the number line that are more than or equal to 2 units away from 0 on the number line. So here's how I like to approach these. I'm going to I'm going to write two different equations. The first equation, I'm going to write this, or not equation, inequality. I'm going to write this inequality without the absolute value symbol. Okay, just like that. Everything else is the same. So I call this, I have my two different paths. And I call this the light side, and then I have the dark side. So on the dark side, the part inside the absolute value, I'm going to leave it just as it is. But then I'm going to make changes to this part that's not in the absolute value brackets. So I'm going to do two things. I'm going to flip this symbol around. So instead of the arrow pointing to the right, it's going to be pointing to the left like that. Okay? And then I'm also going to change the 2 to a -2. So these are going to represent the two spots that are 2 units away from 0 on the number line. Okay? All right. Then I'm going to solve both of these, and then I'll have my solution. So on this left inequality, I'd have to subtract 3 from both sides to isolate the x. So that will cancel. Okay, so I've got that piece. Over here, I'm going to subtract 3 from both sides. And then -2 minus 3 would be -5. Okay, and I have both of these things happening on the same number line. So I've got numbers that are less than or equal to -5. So I've got a closed dot there. Okay, and numbers less than or equal to -5, like -6 or -7, would be that way. Okay, with the -1, I've got a closed dot, and I've got numbers that are greater or equal to -1, and they would be in that direction. Okay, so since you can't be in both these regions at the same time, this is one where you technically want to put the word or. Your x values are going to be in this region or in that region. Okay, and you can always test these out. You can pick a number that should be in the solution region, like -6, and try it out, and it should work in the inequality. It should give you a true statement. Or if I plugged in 0, that should also work. Okay. All right, so let's try another. I'm going to split this again into the two paths. So I've got my light side, which I basically rewrite the inequality and just without the absolute value. Then on my dark side, I'm going to make two changes. I'm leaving that part as x minus 2, but then I'm going to flip the inequality symbol, and I'm going to change the 5 to a -5, like so. Okay. So then I'll solve both of these. Here I'll add 2 to both sides. So x is greater than 7. And over here I'm also adding 2 to both sides. But now I have x is less than -3. -5 plus 2 is -3. Okay, so let's put these on the same number line. I've got an open dot above the 7, and I want x is greater than 7. Those are numbers over here. And then x is less than -3, so an open dot and numbers less than -3 would be over here. So this again is going to be or, because you can't be in both those regions at the same time. So the or ones are going to be the ones that are out like this. The and ones are when it's joined together in the middle on the number line. Okay. All right, let's try the next one. So same kind of deal. 2x plus 1 is less than 5. That's the light side. And on the dark side, I'm going to flip the inequality and change that to a -5. Okay. Then I'll start solving for x on both of these, so getting the x by itself. So I've got to get rid of the 2 and the 1. Well, I need to subtract 1 first, using PEMDAS in reverse here. Okay, so 2x is going to be less than 4. 5 minus 1 is 4. And then divide by 2. Okay, if I were to divide by a negative number, I'd have to flip the symbol, but I divide by a +2 there, so I don't have to flip it. Okay. Same steps here. I'm going to first subtract 1 from both sides, and then divide by 2. And I got x is greater than -3. Okay. All right, so got an open dot above the 2, which I didn't leave myself quite a, I have to add the 2 into the graph there. All right, so got an open dot there above positive 2, and its numbers less than that, so they're going to be going that direction. I'm not going to draw the whole arrow yet because I want to get this other piece in. Above the negative 3, I've got an open dot, and x is greater than that, so numbers that way. So these are going to join together like that, okay? And this would be and for that reason. You can have a number like the number 1 is it's to the left of 2, it's to the right of negative 3, so you can have those be in both places at once, so we use the word and. Okay? You can also write this as all as one inequality for your solution. So you put I take my 2 numbers, my least number and my greatest number, and I put them in order like that, and I put the x in between them, and then I think, okay, between the x and the 2, alligator's eating the 2. Between the x and the negative 3, the alligator would eat the x. And so this means the same thing. Okay, those are both equivalent. All right. Okay, let's look at the last page then here. I've got the absolute value of x minus 7 is less than negative 6. It's tempting to just start splitting it into 2 paths and start solving for x. And you could do that and you would get a solution, but you have to be careful on these problems. This is saying that this quantity, the quantity x minus 7, is less than 6 units away from 0 on the number line. So less than 6 units away from 0 on the number line would mean it'd be a negative distance away from 0. This represents a negative distance, which is impossible. The distances always have to be positive, okay? So that means that this has no solution, and you really just need to be on the lookout for that, okay? So if the absolute value is isolated like it is here, make sure that it doesn't say that quantity is a negative distance away from 0, okay? On this next problem, the absolute value isn't isolated. So that would be the first step. That hasn't happened yet. All the problems so far, our absolute value has already been isolated. But if it's not isolated, you'd first want to isolate it before you split anything into different paths or even think about if you have a negative distance or not. So that's going to be my first step, is to add 3 to both sides. Okay, now I've got it down to this. The absolute value is isolated. I can see, okay, greater than or equal to 8. That's going to be a positive distance away from 0. That's good. So this will have a solution that exists. And now I can split this into the 2 paths. So I've got my light path. Just rewrite it without the absolute value symbol. And then the dark path. Do 2 things. Flip the inequality symbol and change the 8 to a negative 8. Okay. And now I'll solve both of these by, both of these I'm going to need to subtract 2 from both sides of the inequality to isolate the x. So x is greater than 6. 8 minus 2 is 6. And then over here, negative 8 minus 2 would be negative 10. Okay, so then let's look at those. So above 6, I've got a closed dot, because that's underlined. And I want numbers greater than 6. Those would be over there. And then negative 10, whoops, I didn't leave myself enough space. So, gotta extend this a little bit. Here would be negative 10. So I'm doing a closed dot above the negative 10, and its numbers less than or equal to negative 10, which would be over here. So this is or. You can't be in both those places at the same time. That's why it's an or, okay? All right. Next problem. All right, got to isolate the absolute value first. So I want to get rid of the negative 7 and the 3, and we're using PEMDAS in reverse. So I'd first want to add 7 to both sides. And negative 1 plus 7 would be 6. And now I'm going to divide. Don't distribute the 3 into absolute value. You can't. I see people try to do that sometimes. You can't distribute into absolute value the way you would into parentheses. But I can just divide the whole inequality by 3 because this is 3 times that absolute value. So I'm doing the opposite there, dividing by 3. So now I've got the absolute value of x plus 1 is greater or equal to 2. Okay, so that means it's a positive distance away from 0. That means I can split it into the two paths. So my light path looks just the same. The dark side, I'm going to flip the symbol and take the opposite of the two, like that. Okay, and then let's solve both of these. I just have to subtract 1 on both sides of both inequalities here. Then those 1s will cancel. So now I have x is greater or equal to 1, and x is less than or equal to -3. Okay? Man, all my number lines are off a little bit, but that's okay. So here's 1. I'll fix those on the note-taking guide. So I've got a closed dot above the 1, and its number is greater than that. Okay? I've got a closed dot above the -3, and its number's less than or equal to that. And then this is another or 1 because it's split like that. You can't be in both places at once, but you can be in one of those places or the other. Okay, and that's the end of the section, and I'll see you next time.